In this video, we're going to derive the rules for derivatives of trigonometric functions, and we want to start off with the first one, which would be the derivative of sine x. Before we actually derive the derivative, or prove the derivative, we are going to look at it on the graphing calculator. And so I want to put y equals sine x in for y1. And for y2, we're going to use the derivative function on the calculator, so that's math, and that's 8. That's n. It's either, depending on your operating system, you're going to use its derivative with respect to x. Now, you can just type sine x in here if you want, or because it's not that hard to type in, or we can go to the vars menu and go y vars, function, y1, and then instead of taking the derivative at a specific value, we want to take the derivative of x with respect to x for all x. So we let x equal x. For those of you with older versions, you're going to use n-deriv, and it's going to be y1. So you're taking the derivative of the function that is in y1 with respect to x for every x. And so you can use that notation. I also want to graph the derivative using a different kind of line. This time I'm not going to use the line with the hole at the end or the circle at the end. I'm going to use a thick line. So keep hitting enter until you get the thick line, or you could use the broken line too. Okay, and now I'm going to do a zoom trig. So a zoom 7. That'll give me a nice negative 2 pi to 2 pi window. Here's your sine function. Here comes the derivative of the sine function. So at this point, I'd like you to pause the video just for a few seconds or a minute and see if you can make a guess as to what you think the derivative of the sine function is. Alright, so when you look at this function, the derivative function, it certainly appears to be the cosine of x, which in fact it is. The derivative of sine is cosine. And look at some of the key features. It makes sense. Let's look at so the thin line is our sine function. And wherever the sine function has a horizontal tangent, the derivative function has an x-intercept, and that works there. We can see here we have a horizontal tangent for sine, and the cosine has a 0. Horizontal tangent for sine, cosine has a 0. So our job is to actually prove that. So we're going to start by using the definition of a derivative, and in the middle of this video we're also going to use some trig identities. So you may have to review those a little bit, whether you still have your pre-calc book or you can go online. So I know that d dx of sine x is going to equal the limit as h approaches 0 of sine of x plus h minus sine of x all over h. So just using the definition of a derivative. Now the next line, the limit as h approaches 0, the sine of a sum, there is a formula for that. The sine of alpha plus beta equals the sine of alpha times the cosine of beta plus the cosine of alpha plus the sine of beta. So I'm going to use this with x and h. So we've got the limit as h approaches 0 of sine x cosine h plus cosine x sine h minus sine x. So this whole first piece here is just the sine of x plus h, and then you've got your f of x minus the sine of x over h. Now there's two more limits, both of which we've seen before. We evaluated them on a calculator, and so we're going to use these limits to help us prove this. So a known limit is the limit as h approaches 0 of sine h over h is equal to 1. Now we looked at this on our calculator and we let x approach 0, and we had the sine of x over x is equal to 1. And another known limit is that the limit as h approaches 0 of 1 minus cosine h over h is equal to 0. So we're going to actually use these in the proof. Alright, so the next line I'm going to rearrange a little bit so I can do some kind of creative factoring. So I've rearranged, just taking the cosine x sine h and putting it in front of the sine x cosine h. And actually, I'm going to erase here. I'm going to factor out a sine x right here just to save some space. If you factor out a negative sine x, you get 1 minus cosine h. So now I'm going to write these as two separate fractions. There's a monomial in the denominator. I'm allowed to do. Alright, so now you can see I've got I wrote them into two fractions, so I've got this first piece right here is the first term, and then this sine x times 1 minus cosine h over h right here. Now I know that the limit as h approaches 0 of sine h over h, this term right here, is equal to 1. I also know that the limit as h approaches 0 of 1 minus cosine h over h is actually equal to 0, this piece right here. So the first term, the limit as h approaches 0, I'm going to get, this is going to be cosine x times 1 minus sine x times 0. So the answer is cosine x. So we have the derivative of sine x is equal to the cosine x. And so this is one derivative that you need to learn, and should be, you should memorize that.